Well, as I noted at the when I talked about our speakers, Jeremy Adams is with Object Computing. They support OpenDDS and have been working on an RMW implementation for ROS2. But one of the things that's come up regularly that they've been thinking about, and Jeremy has been thinking about, is like, okay, well, what is this gap with hardware interfaces for ROS2, and particularly the industrial robot interfaces for ROS2? So Jeremy's going to share a little bit on that topic. Jeremy, the floor is yours.
Thank you. And I'm assuming you can see my screen at this point.
Oh, sorry. Yeah, it looks good.
Okay, great. Okay, so as Matt said, I'm Jeremy Adams. I'm with Object Computing, also known as OCI. We're going to talk a little bit about hardware interfacing and specifically a reference implementation for that. And we'll kind of get into what that really means here in a little bit. But first, a little bit about OCI. So Matt mentioned OpenDDS, or maybe he didn't. He mentioned our RMW. We're the home of OpenDDS, which is one of the longest continuously open source DDS implementations. We also have practices in analytics and machine learning, blockchain, software engineering, IoT and industrial IoT, cloud, and systems integration. So a little bit about me. I've worked on a wide variety of platforms, including UAVs, ground vehicles, AMRs, and industrial manipulation. A lot of the work that I've done was embedded software systems. I'm interested in the performance of a system, best practices in software engineering, and creating robust and flexible solutions. In my experience in all these different industries, I've seen a lot of different ways to solve problems and a lot of different ways to communicate with devices and control and basically actuate a robot. So real quick, just kind of show you, I worked on some UAVs. In this case, it was flight computer and some ground station software. I've worked on at ASI, worked on a lot of outdoor ground vehicles, tractors, dump trucks, this kind of thing. And then at ASI, we also started in 2016, early, we started working with ROS-1, ROS-2 in our custom framework. And the thing I liked about it, even back then, was that I could develop, and this is running on a TK2 NVIDIA board. So I saw a lot of hope in kind of moving towards embedded systems. And lastly, was at Honeywell prior to OCI, working on the truck unloader and the packet picking cell. And in that case, we were using ROS-1 and PLC communication with Ethernet IP and SIP, and also some custom frameworks. So before we get into the solution, today, how do we use our ROS? What are kind of the aspects of using ROS? So we have reusable components. We have reusable messages. So this is a little message file. We have nodes that we can create separate instances on a running system. We have packages that we can package up these similar software components and some of their dependencies and reuse that. We also have open source software, and the open source software is nice because you can not only use it, but if you really want to, you can look inside and modify that code. We can use a variety of different robots, and we also create our custom drivers, meaning an adapter from this robot's custom interface into something that ROS readily understands and can use. So like I said, let's see, reuse, the slide comes up. So reusing those components not only saves us time and money, but also with business-friendly licensing, we can use that and resell it. open source software. Like I said, I can read code and understand it. I can use this for mobile and manipulation, and it just basically gives me some idea how to use it. Offers the ability to modify what's there. So not only do I take it at face value, I can change it for my liking. And hardware, you basically scan the offerings from the vendors, and you really have to take off the shelf what they offer and kind of make it work in your system. But there's some things that maybe we don't like. So what's not working? The device features aren't really maybe always keeping up with the need, our needs, the way we want to work with them, the types of capabilities that show up at the ROS interface. So maybe the stated use case is, from the vendor is offering certain features, but at the ROS interface, we can't take advantage or use all those features or performance characteristics. Sometimes we get inconsistent experiences when we move between devices using the same ROS interface. So we might have different latencies. We might have in one system some kind of undocumented feature that changes the behavior slightly, or also bugs that could to cause a difference in our system. And we really lack a way to precisely communicate. Some could argue, but I think we really lack a way to precisely communicate our needs as a community to the vendors. And so this really gets down to, at a high level, it's easy to describe, but once you get down to the bits, bytes, lines of code of ROS, it's really hard to unless they know ROS, and it's really hard for them to kind of understand where you're coming from. And this is where I think a lot of the more difficult problems occur. You can solve this to some degree with like boilerplate code, and the vendors aren't usually ROS developers, so they don't really sometimes get involved. Sometimes they do if you have a good, sounds like today we had a few good examples of ROS vendors getting involved with the community. But more importantly, the ROS community doesn't have access to the code that's running on the system, and nor should the vendors feel like they need to in all cases. Last thing here on what's not working is the hardware vendors, like I was saying, control their own code, but this ROS community is limited in its influence. So we need to we need to figure out some way that these two pieces can work closer together. Vendors often have, at least for some value add, they have some kind of trade secret or IP that they're not sharing with the community. But is there a way that, we can kind of bring that together? So what's new that we can use? So of course, ROS2 comes along, and now deployments are no longer on just Ubuntu. We can run these on, Lou mentioned Windows, and they're, very helping the community a lot with that. We also have a lot of real-time operating systems like VxWorks and some other types of real-time operating systems. There's also more environments like small embedded computers, that kind of thing. Software quality is more of an emphasis now in ROS2. So we have REP 2004, which is not mandatory, but helping us provide better guidance there. The ROS community, since its inception, obviously has gained a lot of purchasing power. If you look at the metrics site, ROS metrics, you can see that the community has grown, but and so has the application. So this equates to money spent on hardware. And I think the vendors are seeing this and starting, some of them have always known it. Others are just starting to kind of understand this community and what it offers. And then we also have DDS, which is, we went from ROS1 having a homegrown pub sub mechanism. And now DDS, with its long history of distributed computing in many mission critical applications beyond robotic control. So it's a robust framework for message passing and shared caches. And the ROS community now has developed this device user experience. So they know what industrial hardware is like and how to use it. So they've kind of learned a little bit more about the devices themselves that they're using. So how can the needs of the community more effectively be represented in the offerings of the hardware suppliers? And this is kind of the thing, right? So you can't really, you have to go to a different way of thinking, I think. So in ROS1 we had open source, which is great, but the vendors aren't really using that. And so we created what I call the reference framework implementation. So this is a way to kind of let the vendors provide a little bit of detail about their system, let the community create some software use cases around that and share it back to implement it on their system. So we have in step 1 here of the cycle, we have the idea of creating a requirements document. And this is a standard practice in DoD and other, like other engagements with clients. But you create requirements, performance, functional, non-functional. You might include some standards like HRIM, which was a good standard, but not or good use of ROS interfaces, but not really followed much anymore. And then you have things like RIA, safety standards, which could be equated here. But basically the outcomes are we create requirements, create some conformance tests, and these are automated so a developer could use them. And then the next step is that the member community or members would review these requirements and do an assessment on the types of improvements that could be made from knowing this interface information. So, and then the third step is they take this list of opportunities, this list of features that are possible with this, knowing the requirements from the vendor, and actually create their own requirements describing interfacing features or what kind of feature that would define what they need in a automated way. So we have creating requirements, acceptance test, and automated test, and that'll help kind of give a test fixture of what we can expect from this new feature. And then finally, you just develop this reference implementation. So once the conformance tests are passing and the acceptance tests are passing and we're meeting our requirements, we have something that we could use. So the final step is to take that reference implementation and actually give the vendors training and some hand-on support. So adding clarification, helping with if there's any problem with certain aspect of the code, walking them through what's going on here. So real quickly, so an example of this, let's say you want to run ROS2 natively on your camera or controller, some favorite device. And in step 1, maybe the vendor says, okay, I have a QNX RTOS, gives you some operating environment variable parameters, tells you that the main thread is running at 50 Hertz. You might specify some latency requirements that have to be met in order to keep a running system, and maybe even some API calls that they would call to your library to run the system. And then, so this would all be defined in step 1. And then maybe in step 2, you determine what works in these requirements and generate, like we said, a list. In step 3, in this example application, we create our requirements around ROS2 and DDS. We might even specify certain ROS2 messages that we're going to use on this interface. We might also specify that we want to use lifecycle nodes to manage the state of the machine. So something like that. And then finally, or fourth step would be in the reference implementation, we're going to use this test-driven development approach to work with the vendor and the member community to implement. And finally, the vendor might get some DDS training here and some ROS2 training, and then supporting with any kind of needs, like we said before. So I guess with that, I hope I gave some insight. So, like basically what I'd like you to leave thinking about is, in the past, we used ROS as an open source. The ROS community created that source and used it for themselves. And what I'm basically saying is it's time to establish a little different relationship with the vendors and maybe come up with the things that we can now run on their system, because ROS2 is capable of that. And so is, all these, the software that we're capable of developing is something that could run on an embedded device or a vendor platform. So coming up with the requirements and doing kind of this working together process of creating an example implementation that's test driven and can run on their system directly, and then providing the support to get them over the finish line kind of gives us better features and quicker turnaround to those new features, and a vendor that's happy to satisfy the community.
Well, Jeremy, I appreciate it, and I'm hoping as we get this out there and talk a little bit about circulate this a little bit more, let people think about it. As more people get their hands on ROS2, and trying to actually make robots move, there'll be plenty of these opportunities to revisit what you talked about, right? So,
yeah, appreciate that. Yeah, I think it's time to kind of rethink how we use open source and where it can run. So, thanks for your time.